Welcome everyone, and welcome to Hugging Cast. Hugging Cast is a live show about building AI with open models and open source. And in this season, each episode is about learning how to build AI with open models using the work we do with one of our partners. And we're going to do that through live demos. And our goal is that you can walk away from this having learned something practical that you can apply to your use cases in your company. And we want to continue making this show live and interactive. So after the demos, in about 30 minutes, we'll start taking your questions from the live chat. At Hugging Face, we want to build an open platform where we make it easy to use our models and libraries on whichever compute stack you want to use. That's why we work with cloud platforms like AWS, Google Cloud, Azure, Cloudflare, with hardware platforms like NVIDIA, Intel, AMD, and on-prem platforms like Dell and IBM to build all these experiences that make it easy for you to build your own AI with open models. And in this episode will be all about our collaboration with Google Cloud. And we want to show you how you can accelerate your work building AI with open models on Google Cloud. And to demo our work building with Google Cloud, it is my pleasure to welcome Philipp and Alvaro to the show. Do you want to say hello while I share my screen?
Yes, hi everyone. Awesome to be here again and looking forward to what we can now do in Google Cloud.
Hello, guys. It's the first time I'm here, so I'm very happy and very excited to be part of the show.
Awesome. I take the banner off and I'll go full screen. And so this is all about our work with Google Cloud, and what we want to show you today is how you can leverage that to deploy open models on Google Cloud. And this is something that Philipp, you actually went to announce and demo on stage. It was just a couple weeks ago at Google Next, where you were invited on stage during the developer keynote. So really cool to show you everything that you demoed just a couple of weeks ago. And I talked about, okay, we want to show you how to deploy models on Google Cloud. We're actually going to show you 3 different ways through which you can do that. You can deploy models on Google Cloud with Hugging Face, on Hugging Face with our Inference Endpoints product. Then we will show you how you can do the same directly within Google Cloud using the Vertex Model Garden. And last, Alvaro is going to show you how you can deploy large language models on TPU with our new library. So a little bit of context. What is Hugging Face Inference Endpoints? It is our easy way for you to take a model on the hub and staying on the hub, just deploy that on infrastructure that is managed by Hugging Face. And now we have the Google Cloud option. I will show you how it works in a minute. In Vertex Model Garden is within Google Cloud an easy way for you to access state-of-the-art models, open models, proprietary models, and today with our Hugging Face integration, you can do that with models from Hugging Face, and you can do that on Vertex and Google Kubernetes Engine, and Philipp's going to show you that in a few minutes. And you can access that experience directly from the hub as you look at a model that you want to deploy, and you can access that experience directly within Vertex Model Garden. There's a new deploy from Hugging Face UI that allows you to do that. Okay, and third, I told you about deploying large language models on TPU. We have a brand new library to do that. Alvaro is going to show you all about it. It's called optimum-tpu, and it's live today on Hugging Face's GitHub. All right. Enough about the slides. Let me come back to this and then jump onto the demo. All right. Switching my screen sharing. And there we go. Okay, so to do this demo and use Hugging Face Inference Endpoints to deploy a model, I wanted to start with a Gemma model. If you don't know, just about a month ago, Google released a new family of open LLMs called Gemma. They come in a variety of sizes and different fine-tuned, so you can find 2 billion parameter model, 7 billion parameter model, the base model, instruction-tuned model, and models that are already set up for Llama CPP. All those checkpoints you can find on hf.co/Google. With further families released with recurrent Gemma and code Gemma. So now, switching to Hugging Face inference endpoints. I'm here on the UI to create a new endpoint, and I will show you just how easy it is. So as I said, I'm going to focus on Gemma. It's really easy to find. If I type Gemma in the model box, I can find all the different variants. The one I want to deploy today is the instruction-tuned 7 billion parameter version. And so now it is selected. Next, I want to select the cloud on which the model is going to be deployed on dedicated infrastructure. And that's what we announced. That's what you announced, Philipp, today. 2 weeks ago at Google Next. So we now have Google Cloud Platform as an available option. It is selected here. And within Google Cloud, I have access to a variety of GPU options today. And for this deployment, I'm going to choose an L4 with 1 GPU to deploy Gemma 7 billion. Because Gemma is a large language model, it is recognized by inference endpoints. And so by default, I am offered the text generation inference container so that I can benefit from all the production optimizations and get the best throughput for the model right out of the box. Now, a very cool option that you have is to set how you want the model, the endpoint, to scale to 0 if there is no activity. By default, you can just leave it always on. But if you want to control your costs and say that if nobody is sending requests to the model within 2 hours, you can select that right there. And if there is no request within 2 hours, then it will spin down and you will stop paying for the capacity. So that is automatic scale to 0. So at this point, that was just 3 clicks and everything is ready for me to set up that endpoint on Google Cloud. Because it is so quick, I will show you some advanced options to do that as well. So I told you about automatic scale to 0. Well, you can also set up auto scaling so that the endpoint scales up if you get a lot of concurrent requests. And the way to do that is simply to increase the number of maximum replicas for the endpoint so that if you have a lot of concurrent users here is going to spin up additional replicas at the model. And of course, your cost will scale as a result. You can see here the default option that have been selected for this model repository. It's a text generation model. I'm using the PyTorch framework. I'm not applying any quantization. All of these things, including the max input length, the max batch prefill tokens, can be set up and modified here before we create the endpoint. I'm going to use the default option and then just go ahead and create an endpoint. So because it is, I selected the L4 GPU, what is going to cost me is just $1 an hour while the endpoint is up and running. All right, let's go and do it. So now the endpoint is starting and I can monitor what's happening under the hood. If you don't want to wait for that, I actually just created one before the demo. So I have an endpoint running with the same model. Once I have an endpoint up and running, I can very easily see what is going on with it. I have access to analytics to see how many requests have been received, how much memory it is using. I have access to the cost. So here, the endpoint's been running 37 minutes. Actually, it's spun down and scaled to 0. So it went from 1 replica to 0, and now it's back up. I have access to the logs, so I see everything that happened within the container. And I have access to the settings. So all the great stuff that I showed you before, you can, after the fact, manually change and update your container on the fly. Great. So now that the endpoint is running, maybe let's test it out. So the meaning of life is, what is the meaning of life? I don't know. Let's see what Gemma says. So here, if the endpoint is scaled to 0, it's going to spin back up the replica. And the meaning of life is a profound question that has captivated philosophers, artists, and individuals throughout history. Okay, well, count me in on that. Great. I guess that was quite a quick demo. It was quite a quick demo because it was pretty easy. We're working hard to make inference endpoints as easy as possible, whichever model you want to deploy. So really excited that today you have the option to do all these great things on Google Cloud and make it a 3-click experience to go from looking at a model repository to having dedicated infrastructure on Google Cloud so that you can just send requests to your live endpoint. That's what I had for you. It was the first demo, like how to deploy a model on Google Cloud directly from the Hugging Face hub. Next,
Awesome.
I want to hand it over to you, Philipp, and so you can show us what's happening on the Vertex side.
Yeah, but before we go in, maybe something I can add for like the inference endpoint. So as you have seen, we currently have like 3 different instance flavors for GPU. But we are currently working on adding H100, A100s, and also TPU. So what you will see later by Alvaro will also be soon available for you in inference endpoints. So expect more GPUs and like different accelerators to come there as well to scale to bigger models and have huge throughput numbers. And as Jeff showed you how to deploy Gamma, I think I will take the opportunity and show you how to deploy Llama 3. I guess every one of us has seen last week the amazing announcement from Meta with Llama 3 and how powerful it is. And Llama 3 Instruct is available on the hub. I already made sure that I have access to the model. So if you want to deploy it either on Inference Endpoint or on Google Cloud directly, you need to make sure you have access to the model. And different between the option of Inference Endpoint and Vertex AI is that on Inference Endpoints, Hugging Face, so we manage the infrastructure. So nothing is running inside your Google Cloud account. You more or less run inside our Google Cloud account and get access to the endpoint. But of course, that's not available for all companies. And sometimes you want to deploy, I think we lost the screen. Sometimes it's like you are interested into deploying the model inside your own environment because you need to have some data not leaving into the external network. Maybe you want to have closer integrations so that some applications are closer to the LLM to reduce the overhead. And sometimes you just have some cloud credits you want to spend for LLMs. That's like the right solution to do it. And as Jeff already has shared, next to the inference endpoints option, we have a Google Cloud option. And when I click on it, I will automatically be linked into my Google Cloud account, into Vertex AI, where Vertex automatically retrieves the model from Hugging Face. So we can see here the huggingface.co URL and then our model ID. And here we have Vertex AI. We can select the region we want to deploy. So if you are in South America, you can like easily switch to South America. I think it will choose the default region, so maybe you don't even need to adjust it. And then very important now here is we need to provide our token. I'm not going to do this because it's in clear text. So make sure if you demo it or if you use it, that the token here will be in clear text. We can change our model name similar to our endpoint, and the instance type is automatically pre-selected for us. So we don't even need to think about which GPU we want to use. Google takes this away for us. Similar to Jeff's demo, we use the NVIDIA L4, one accelerator count, and then I can click deploy, and our model will be created. And since we don't want to wait,
just one quick comment from me. Why is it important to add your Hugging Face token? So probably you've requested access to Llama 3 on Hugging Face. And yes. So your Hugging Face token is used so that we can tell Vertex, Hugging Face can tell Vertex that you have access to the model and it can be downloaded. But your endpoint that's deployed, it's within your own Google Cloud tenancy.
Yes, so I requested the access, and also for a model I deployed earlier, I added my token and it created my endpoint. And the endpoint will appear on the Vertex model garden under your model registry. So if we go to our model registry, we can see that we have one running endpoint and one endpoint which is currently being created. Let's go back to our endpoint. Oh no, I lost our inputs, but we can also test it directly. And for Vertex AI, it's a bit different. So it's not directly like the inputs you might know from text generation inference. You have this instance object, which includes our payload. So we have the instances and then our payload. Take it simple without the llama prompt. Maybe what is deep learning, and then we also want to make sure we define some parameters to not generate too much token. Max new tokens, let's say 25. And then we can test our endpoint. And then we get deep learning as a type of machine learning. A type of machine learning that uses neural networks with many layers to classify and process request input data. And that's how you can directly test your model in the UI. And in addition to this, you can, of course, use all of the Vertex AI SDKs with Python, with JavaScript, or even like basic HTTP, but where you need to make sure you provide your credentials in the authentication header. And also super cool about this, directly inside here, we can also view the logs of our endpoint. So if you are curious, okay, how fast was my request or my response, you can more or less like go into the logs where we see our request. Let me make it a bit bigger, where we have our input parameters and where we also have the total time. So it took 1 second. We had a queue. It closed it again. Whoops. That's the wrong one. There we have it again. 1 second. We didn't have any queue, and we had a time per token of 66 milliseconds for our input. So that's the how to deploy from Hugging Face from Vertex AI. But what if you are already like me currently in Vertex or in Google Cloud? How can I deploy my model there? And that's what Jeff teased in the beginning. So if I'm already in Google Cloud, or if I know what model I want to deploy, I can go to the Vertex AI model garden, which is under Vertex AI and then model garden. And in here, there is a new deploy from Hugging Face option. And it's what's pretty cool about this deploy from Hugging Face option. It opens the same sheet we had on the site, similar to Llama 3, but this time we can search for model. So we did Llama, we deployed Llama. The next best popular open LLM is Mistral currently, right? There are a lot of Mistral models, so I can directly search for Mistral AI and then can select, for example, the Mistral instruct one. Or I can say, okay, what community models are there? We know that newest research has a pretty good Hermes model with DPO fine-tune. I can select the community fine-tuned models as well. And similar to the model where we went from Hugging Face to Google Cloud, we can have pre-selected GPU instances. We can change our model name. We can change our input type. We can provide our Hugging Face token. And in addition to this, we also now have a Google Kubernetes engine tab where we get instructions on how you could deploy the model to GKE. It's more or less a Kubernetes manifest with our deployment, where we have our TGI container, where we have the request for our resources, and also the TGI parameter, which are used to start a model. So we have our model ID here. We have, again, similar parameter you have seen by Jeff with max batch prefill tokens, max input length, which you, of course, can modify. And then we also have our accelerator with our NVIDIA L4. So if you have a running Kubernetes cluster already, you can simply copy the manifest, use kube control to apply it, and then get your model deployed on GKE. If you don't have a cluster running, we also have included instruction how to create your own cluster if you want to use GKE instead of Vertex AI.
That's amazing. Thank you so much, Philipp. And so at the end of the day, I show you how to deploy the models from Hugging Face. Philipp, you showed how to deploy a model within Vertex AI. And once these endpoints are running, what's the main difference? Well, the difference is if you do it from Hugging Face, the infrastructure is managed by Hugging Face. said differently, it's under the Hugging Face tenancy. If you do this within Vertex AI, it's going to be within your own tenancy. So really cool to have the ability to do it either way. Next, I want to hand it over to Alvaro. And Alvaro is going to show us something really, really cool, which is how you can deploy your models, your large language models on TPU, which is a brand new sort of option enabled by a new library. I don't want to spoil the beans. I'll let you take it from here.
Yeah, so thank you, Jeff. So first, thank you everybody for being here. So first thing I wanted to do is just like a very small presentation, just to tell you a little bit about what's the idea of having the endpoints on the TPUs and why we're doing that. So first thing is, you already know, as you listened the presentation apart from the Jeff and Philipp, what's Google Cloud and what they can do. And they offer a large amount of options on GPUs and on compute. What we might not know, or it might not be well known, is the TPUs they have. So Google is one of the biggest company in terms of computing power, and they designed their own custom-made hardware, that's a tensor processing units. And with this, that they're able to accelerate as much as possible their machine learning activities and tasks, and they provide that to the public. So obviously, when we started our partnership with Google, one of the objectives was to make the TPUs available through the Hugging Face experience. That's why we started optimum-tpu. We're still developing a lot on that, but we already have some results, and that's what we want to show you. So the idea is that so far we have to launch the TGI endpoints on the terminal so far. The reason is because we haven't finished the UI, but it's coming soon. So once it's done, probably very soon, you will be able to do just one click away, and as Philipp showed, it's just going to be one more option, and you will be able to spawn a new endpoint on a terminal using the TGI. The options are actually very simple. You have to say fill the JSON so far. So you have to say something like, it's nothing fancy, like the model name, the version, the provider, the region, and stuff like that. So it's very, very easy. Once you do that, you are able to get to the endpoint page that you might be already familiar with. And with that, you basically have the endpoint up and running, and you can play with that. So it's really, really that simple. It's nothing else than that. Let me do one more thing then. I just wanted to show my screen so I can actually show the fact that it actually works live, and it's not just something that I'm faking or anything like this. So as you might see here, this is the very command I showed you earlier, and this is the way we will launch it. And once you do it, it will answer right away, and it will actually spawn a new endpoint over here. So if you reload, you will see that there is a new endpoint initializing here. Just for the demo idea, I don't want you to keep on waiting to see the endpoint up and running. So I just spawned a few more beforehand. So you can see that the endpoint UI is available here. You have all the information, the endpoint URL, the container URI. This one, you can use it to integrate with your own application. So you can use it to send requests to your endpoint. And you can see the model, the instance, where it's loaded, and all the information, the logs, the settings. And with that, you can really interact. You can you actually have also a small test example that will allow you to interact with this. So let's just try to put, like, say, a few tokens, and I'll pick one of them. I'm very lazy, actually. I just run one of the the predefined examples, and you will see that it will run straight away, and it actually generates the text as it goes, and it does exactly what it's expected to do, and it's running on TPU, so on the real dedicated tensor platform processing unit that's been designed by Google. So please stay focused on what's going to happen on optimum-tpu, because we're going to add more more support on that. We're going to add more models and accelerate on them. We're going to provide also some inference. I see some people asking about JAX inference and training. We're definitely working on that, and that's going to come soon. We're first going to finish the UI, and so everybody's going to be able to start working on the PyTorch version, but we're definitely working on the JAX inference as well, and training is coming soon as well.
Great. So, yeah, Hetman asked, will they need to write your own JAX inference or training, or does optimum-tpu handle it for you?
So we're going to provide something that will simplify. We're going to provide a trainer and for the training, and for the inference, everything is going to be as simple as it is with the transformers module so far. So it's going to be quite easy, I think.
Really, really cool. Thank you so much, Alvaro. Happy to go to the live Q&A part of the show. There was another question from Hatman, or no, was it from Ege, while I was demoing Hugging Face inference endpoints. And it's a great question, which is, can I infer any custom model using Hugging Face? And during my demo, because I had selected a GEMA model, the inference endpoint sort of automatically selected for me a text generation inference container. But of course, if you select any other model that is supported by inference endpoint out of the box, then it will give me a container that's appropriate for the model. So any sort of transformer model is going to be supported, any diffuser model is going to be supported, any sentence transformers model is going to be supported. There are also other libraries on the hub, third-party libraries, which use the hub to host repositories. And basically, you can deploy any model, any custom model, whether or not it's compatible with our libraries using inference endpoints. We enable that through a couple different in a couple different ways. If it's using supported library, you can add sort of custom inference through a short Python file that you add to the repository. If you want, for instance, to add additional pre-processing or post-processing steps. And then if you need a completely custom runtime, then you can bring in your own container to be deployed on the infrastructure managed by Hugging Face inference endpoints. Did I miss anything in there in that answer, Philipp?
No, it was perfect.
Thank you. I learned from the best. Okay, then next, Hatman had a question for you, Philipp, as you were demoing how to deploy in Vertex. And so do they offer TPUs on there, or what choices are available?
So Google introduced new versions of TPU with TPU v5e on like the latest Google Cloud Next. Those are not yet available in Vertex AI. So if you plan to deploy on TPUs using optimum-tpu, the first step will be GKE, but they are coming to Vertex AI as well, but we currently don't have the information about when. But they're like, so what you have seen in the Vertex AI model garden with like all of the models where you can select Vertex AI and GKE, there we will have GKE TPU supported snippets as well to make it super easy for you, so that you don't need to think about, okay, what PyTorch XLA TPU version do I need to run in my container? So that will be all abstracted away for you.
That's amazing. Thank you, thank you. And then I had a follow-up from Ege about Hugging Face inference endpoints. So how can I set prediction inputs and outputs for the endpoint contract? And I think that touches a little bit to that custom Python script. Do you want to give a little bit more detail, Philipp?
Yeah, so by default, what we do on Inference Endpoint is if it is a text generation task, we use TGI. So TGI has its own defined input and output schema and supports the OpenAI format. So if you are wanting to use the OpenAI SDK, you can do this with Inference Endpoints and any Open LLM, more or less. If you are more working on custom models or custom code with like custom pre and post processing, we have something called Custom Handler, which is a single Python file called handler.py, which receives a JSON and responds with whatever you want. And the input and output schemas are defined via HTTP headers. So if you are sending binary data for an image and want to caption it and has written like a custom handler, you need to add the content type in your HTTP header and also the acceptance type in your HTTP header to tell the system, okay, I'm sending you an image PNG and I want back a JSON. And that way the pre and post processing abstracted away from the handler takes care of it. And inside your handler, you receive the image directly or can return like a Python dictionary, which will be converted into JSON.
Awesome. Thank you so much. That was a great way to show you our work with the Google teams. We work with them day to day on all the experiences that you've seen today. So again, not just one way, but 3 different ways that you can today take an open model, an open weights model on Hugging Face and deploy that on Google Cloud, whether on infrastructure that's managed by Hugging Face or that's within your own Google Cloud account. And now with our new optimum-tpu library, you can even do that on a TPU in your own account for the supported models. Thank you so much. Yes, this session is being recorded. It's going to be available on demand at the same URL you're watching it right now, and we'll post it on YouTube later on today. So thank you so much, and have a great day.
Bye.
Bye.